In this video, we're going to continue on with activity 313, basic inputs programming. In this one, we're going to focus on part 4, dealing with the optical shaft encoder. So with this, we do have the part 3 code is still up here. We're going to get ready for part 4. So I'm going to go up to File, Save As. Save this as part 4. Then I can go through and just change some of the parts that I need to change. So for example, rather than using the potentiometer, we're going to use the optical shaft encoder. I can start to take out some of the pseudocode and some of the program that I had from part 3. Give us a little bit of room here. In part 4, we have some sample code that's going to be provided to us, so that way we can get to kind of be familiar with how the encoder is programmed. So I'm going to go ahead and copy that, put that into our task main. And what we can do here is we can start to look at, well, what is it that exactly are we going to do? Is we're going to turn the left motor going forward at half speed. We are then going to go ahead and we're going to do the same thing with the right motor. So I'm going to copy this line and just change the name of the motor. And then we are going to, until the encoder counts to 480, and then we're going to say to stop the left motor and stop the right motor. And let's go ahead and comment this. So again, I can go up and always grab my pseudocode. I'm just going to copy it and paste, and just go ahead and add my comments as I need, and I'm just going to make some adjustments as I do so. Okay, so this would go through, and let's go ahead and this would go through and finish out some of the documentation, pseudocode, and the steps we have. So let's go ahead and compile the program, see if there are any issues. Let's download the robot. And before we get started, one thing we may want to do is verify this program is set up so that way that the encoder right now is reading at -127, so we're at a pretty good thing. If I need to turn the encoder to a direction, I'm gonna get it to be around here. I got it down to -2, but I'm gonna go ahead and hit start. So what's gonna happen is the two motors are gonna turn on until the encoder until the encoder is gonna count to 480, and then it's gonna stop. So I'm gonna hit start. Both the motors are turning on. You watch your debug window as well. I'm going to keep turning my encoder, and then once it gets to hit 480, then it stops the motors. So that's kind of how the encoder works, is it counts how many rotations of a shaft or axle that it would take, and it can be used to help control the motors. Now, as we go on to take a look at the rest of part 4 here, they want us to go ahead and I'm going to grab this pseudocode, and we're just going to copy, and we're going to stop our previous program, and let's go ahead and let's paste this into the pseudocode that we have here. I'm going to take out the lettering and tab this over so that way it all lines up. We want to turn both motors on forward until the encoder counts. So here's where we can start to kind of separate into basic behaviors. Turn on, we'll go ahead and say left motor forward. Doesn't say what speed. I would say let's go ahead and let's just use what speed that they have. So we'll do at half speed. That way that's a little bit less work we kind of have to do. Doesn't really matter. You can go full speed if you want, or three-fourths, whatever that may be. I'm going to copy and paste that line and do the right motor. Change some of our syntax here to match. Until we count 480 degrees, and then turn both motors on in reverse until 3.5 rotations of the encoder have passed. So as you take a look, we can go ahead and start to kind of look. This is where look at what we got to do next. So let's go ahead and grab this until. We'll throw that down there. Turn both motors on in reverse. So let's copy this. These first two lines. We'll take these out and paste that in. Instead of forward, we'll say in reverse. They don't say what direction, or I mean not what direction, but what speed, I should say. And so we're just going to keep it at half speed until another 3.5 rotations of the encoder have passed, and then we want to go ahead and turn off both motors, which we'll go ahead and change this over to a stop right motor and stop left motor. Okay. All right, so the thing is, as we start to write the code, turn on the motors going forward at half speed are already there until the encoder counts 480 degrees, and then they want us to go ahead, so I'm going to go ahead and hit enter to make a couple of lines. We don't want to get rid of these lines because they are going to be part of the last part of the program. But what I can do is grab lines 32 and 33, copy them, paste them in, change the directions over, change the comments, and then they say until another 3.5 rotations. So I'm going to go ahead and type until encoder counts. Now, the one thing that might be helpful for us is, the question is well, how much does the encoder count with one rotation? Let's go ahead and compile the program. Now, this, you'll notice this command, because I don't have it fully written yet, is throwing an error, and it's going to give a red X. So what I'm going to do is, to kind of keep that going, is I'm going to toggle that to a comment, so that way it gets ignored by the program. And now, when I hit compile, that gets ignored, and I can go ahead and do that. So let's go ahead and download. I can go ahead and download the program. And if I have trouble, kind of knowing what that is, here's what I might do. Let's use the debugger windows to take a look at the encoder. So right now the encoder is reading at 503. Let me go ahead and back this back down until I get to be at 0. Or somewhere close to it. So there my encoder is reading at 1. And as I go through and I take a look, I can then go ahead and I'm going to put my finger on here and I'm going to go ahead and do one full rotation with the encoder and see what value that it stops at. So it looks like it's about, it says about 384. I would assume, just based upon maybe my movement of my finger, it's probably counting at 360 degrees. So in this scenario, I can go ahead and I can look at 360 degrees times 3.5. So just to kind of show visually what this looks like. So 360 times 3.5 rotations would give me about 1,260. So now, if I close my debugger window, I can select that line, toggle the comment. If I click on that red dot, it'll go away. 1,260. And then I have to put in what the sensor is, the quad. And then here, I can grab my pseudocode, put in my comment, and then just go ahead and bring these together. So now I've got everything ready to go. compile the program, download the robot. No errors are being detected. So let's go ahead and the quad encoder, we'll go ahead and we'll put it back down to 0. Let's go ahead and hit start. So there's the two motors there. If I go ahead and turn it till it gets past 480. Now you're going to see it's going to switch, and if you watch the code, the quad encoder automatically went through, and now I'm back down to 18. So once we hit that until statement, it goes through and zeroes the encoder back out. So now, if I go through and continue to go forward, keep going up and up and up, until I hit 1260, then it stops the motors. So there was one part that, some may have thought, okay, well, you said until another 3.5 rotations, so shouldn't we add that 1260 to 480? But actually the encoder clears itself out when it hit that until statement. So that keeps us from having to go through and do that. So if you're not seeing that behavior, where it's not clearing that out, then in that case you would add those two values together to go through and make that happen. So that way it accurately works for your code and the intended purpose. All right, this right here finishes up activity 313, basic inputs programming part 4. Check out part 5 where we're going to start utilizing the line follower and see what we can control with that particular device.